So we're talking about how this chapter opens after it talks about some word parts. It talks about some problems with a gluten diet. Some people have celiac disease and some other sensitivities, but going on a gluten-free diet can actually uh, pose other challenges. Um, Whole grains in which gluten is a natural ingredient are linked to improved health outcomes, like a lowered risk of both heart disease and type 2 diabetes mellitus. Gluten-free foods tend to be more expensive. There may be an added charge for a gluten-free option. Some dieters have claimed that a gluten-free diet has helped them lose weight. However, it is more likely that their weight loss resulted from cutting out unhealthier foods than it did from going. One should not assume that digestive symptoms are caused by gluten, because eliminating gluten from the diet may cause the body more harm than good. Okay. Okay, we saw this is the same thing we saw yesterday. The word that means too is die, I think. Sin means the same or to come together as. Okay. Okay. The importance of macromolecules such as nucleic acid and large proteins adds importance to the study of chemistry within physiology. It wouldn't be mathematics or anatomy, it would be chemistry, because that has to do with molecules. But you can click on it. You can click on it. Chemicals are all around us. They are found in products we use daily, such as soap, toothpaste, shampoo, and deodorant, as well as foods, drinks, and medications. Therefore, it is easy to appreciate that the human body is composed of chemicals, including salts, water, proteins, carbohydrates, lipids, and nucleic acid. As we saw in chapter 1, cells are built from complex chemicals. The study of anatomy and physiology, therefore, begins with the study of chemistry. So chemistry was the answer there. We first examine the fundamental basic structure. Okay. Everything in the universe is made up of hydrogen, space, or matter. Everything is made up of matter. Different kinds of matter, but it's made up of matter. All matter is composed of fundamental substances called blank. These include sodium, iron, carbon, and many more. Okay, I don't know what answer they're looking for, so we need to review that. Everything, oops, go back to, I think everything non-living is made up of matter and occupies space. Mass refers to the amount of matter present. The simplest examples of matter with specific chemical properties are called elements. Common examples include, can you scroll down? Common examples include iron, copper, silver, gold, aluminum, hydrogen, and oxygen. So elements. Matter is made up of elements. These are some of the most common elements in your body by percentage body weight. There's oxygen that makes up 65%, carbon that makes up 18.5%, hydrogen that makes up 9.5%, nitrogen that makes up 3.2%, calcium that makes up 1.5%, and phosphorus, which makes 1%. Okay. Then there's a bunch more. There's trace elements that are tiny. Elements are composed of particles called atoms. They're probably going to ask us that question next. Which are the smallest complete unit of element? Okay. Atoms of different elements vary in size, weight, and by the ways they interact with other atoms. Some atoms can interact or even combine with atoms like themselves or atoms of other elements by forming attractions called chemical bonds, whereas others cannot form such bonds. So all matter is composed of fundamental substances called elements. S, I believe it needs an S. Yeah, good job. Oh, it would have taken the singular. Okay. Within an atom, particles called blank constantly move around the central nucleus. Okay. So they're talking about inside an atom now, particles called blank. So do you remember what's inside an atom that moves around the nucleus?
Would it be cells?
No, cells are made up of atoms. We're talking about inside an atom. Those are where the protons, the neutrons, and the electrons live. The protons and the neutrons go inside the nucleus. I think they're looking for electrons, but let's review it. See, an atom consists of a central portion called the nucleus. That's this thing in the center. And one or more electrons that constantly move around the nucleus. So electrons, these blue ones move around the nucleus. Electrons. What is the meaning of the word element die? Okay, good. bringing it back to you. Good job. Okay, so we completed. What happens to atoms as they form chemical bonds? They gain, lose, or share protons. They gain, lose, or share neutrons, or they gain, lose, or share electrons. When we form chemical bonds, what's happening there? Yeah, electrons. That you were right when you said electrons, because that's how they gain a charge, is they gain or lose electron. They can't share anything in the nucleus. They can only share things on the outside. They gain, lose, or share electron. That's how electron bonds work. Okay. The science concerning properties and composition of substances is called zoology, microbiology, chemistry, or biology. What science do you think it is?
Chemistry.
Chemistry. That's biology. Yeah, there you go. Chemistry is the third one. Good. Nice. The most critical atomic particle in bond formation. So the most important parts of the atom in bond formation are electrons, protons, or neutrons.
Protons.
Remember, they're talking about forming bonds. You can only form bonds with what? There's only one kind of particle that you can form bonds with, and that's electrons. So the most critical atomic particles in bond formation are electrons. Okay. What term describes anything that has weight and takes up space? Matter, mass, living, or elements. Takes up space and has weight, or has weight and takes up space.
Mass.
I'm not sure if it's mass or matter, actually. So why don't you look it up? It's one of those two. I'm not sure which one it is. Everything non-living and living in the universe is made up of matter and occupies space. Mass refers to the amount of matter present. Weight is a measure of the gravitational pull on mass. So if you take up space and you have weight, because they added weight here, that would be, I would think, weight is the measure of the gravitational pull on mass. Because mass is just, if it has weight, I think it would be mass refers to the amount of matter present, but if you have weight with it, so basically you have a bunch of stuff and that's called mass. But if you put weight on the mass, then it becomes matter, I think, is how that works. We can now formally define chemistry as the branch of science that deals with, okay, we talked about that already. Yeah, I think it would be, if it takes up space and it has weight, it's going to be, if your weight is 150 pounds on the moon, it would be only about 25, but your mass would be the same in both places. Because we're dealing with life on Earth, we can consider mass and weight as roughly equivalent. Takes up space and has mass. I would think that would be matter because they added weight to it. So if you go back to the question, the way the question here is worded, it says anything that has weight, so gravity is acting on it and takes up space. Mass doesn't have weight. Mass is just the amount of stuff that's there. So I think it would be matter. I think they're looking for matter here. But this is one of those questions that is a little bit, the way it's worded is, if they hadn't put has weight, then you'd be right. It would be mass. The first electron shell, okay, we did this a while ago. The first electron shell holds too many, how holds how many electrons? Think of the hydrogen atom that we talked about. How many electrons do you have in there? Atoms can attach to other atoms by forming chemical bonds. When atoms form chemical bonds, they do so by gaining, losing, or sharing electrons. The electrons of an atom occupy one or more areas of space called shells around the nucleus. For the elements up to atomic number 18, the maximum number of electrons that each of the first three inner shells can hold is as follows. The first shell closest to the nucleus holds 2 electrons, the second 8, and the third 8. And we're going to talk about making the diagram. So how many electrons does the first shell have?
2.
2. It holds 2. Right. That's what you read. Good job. List 2 major characteristics of elements. The smallest living functional unit of the cell. They make up all matter. They're parts of atoms, and they're composed of atoms. So we need to pick 2 answers here. Remember, it's 2 major characteristics of elements. Elements. What did we learn about elements? Okay, living organisms require about 20 elements. Most elements exist in pure form, but some combine with others. Those are elements of the body. Okay, keep going. We already read the chart before. What else does it have besides the chart in there? Elements are composed of particles called atoms, of which are the smallest complete units of elements. So atoms are the smallest complete unit of elements, but you take atoms to make elements. Atoms of an element are chemically the same, but they differ from the atoms that make up other elements. Atoms of different elements vary in some size, weight, and the ways they interact with other atoms. Some atoms can interact or even combine with atoms like themselves or atoms of other elements by forming chemical bonds. So we need to figure out from the paragraph that I just read right here, which 2 things are true in the question that you are trying to answer. Atoms are the smallest, the smallest units. Atoms are the smallest units, but elements are made from atoms. Right? So there are parts of atoms. Yeah, no, they're composed of atoms. That's okay. They're composed of atoms. And I would say they make up all matter. Elements make up all matter. those two. Okay, now, which two, this goes back to a question that we answered a little while ago. Which two shells, electron shells, can hold a maximum of 8 electrons in elements up to atomic number 18? So which two shells hold up to 8 electrons? Hold a maximum of up to 8. Okay, the third one and the second one. Right, good. Because the first one holds 2 only. Okay, now describe the structure of an atom. Electrons and neutrons within a nucleus surrounded by or encircled by protons, okay? So do you remember what's in the nucleus of the atom? What's in the nucleus?
Protons.
Right, protons and neutrons, right? Usually. So which one says that protons and neutrons are within the nucleus? Right. The other two put electrons inside the nucleus, and electrons fly around outside on the outside. So that's the one. Protons and neutrons within a nucleus encircled or circled or orbited by electron. Okay, so the electrons go around the nucleus. Okay. Okay. The number of electrons in blank of an atom will determine whether or not the atom will interact with another atom. The number of electrons in all of the electron shells, the nucleus, the innermost electron shell, the innermost would be closest to the nucleus, or the outermost electron shell will determine whether it will interact with another atom. Okay, the electron, okay, so we read about that. Keep going. We need to read now. Many complex atoms have as many as 18 electrons in the third shell. Simplified diagrams, such as those in figure 2.2, depict electron locations within the shell of atoms. Okay. Okay, scroll down. The electrons in the outermost shell of an atom determine its chemical behavior because they can only share the electrons on the outside, on their outermost shells. Doesn't matter how many shells they have, they can only do something with electrons, either share them, donate them, or receive more on their outside shell. Okay. So it's the outermost shell that determines how they bond. Atoms such as helium, whose outermost electron shells are filled, have stable structures and are chemically inactive or inert. Atoms such as hydrogen or lithium, whose outermost electron shells are completely filled, or incompletely filled, tend to gain, lose, or share electrons in ways that empty or fill their outer shells. This enables atoms to achieve energetic stability. So the electrons in the outermost shell of an atom determine its chemical behavior. So it's the outermost, the last one on the list. Atoms attach to other atoms by forming what? Which may result from gaining, losing, or sharing electrons. Okay, click on it. Okay, so if you go down below the picture, I think actually that's ions. We're not there yet. Go up. This is talking about bonds. Go further up the page. So it says, okay, atoms that gain or lose electrons become electrically charged and are called ions. So they form chemical bonds. I think further up on the page, go up somewhere. No, up the other way toward the top. Keep going. See, look. See this word? Atoms can attach to other atoms by forming chemical bonds. Chemical bonds. When atoms form chemical bonds, they do so by gaining, losing, or sharing electrons. Chemical bonds. No S on chemical. No S on, yeah. No S on the first word. There you go. That's good. There you go. What is an atom called that has become electrically charged? Okay, we talked about this. What is that word? When when an electron has a charge, what do we call it? When an atom, I should say, has an electrical charge.
An ion?
It's called an ion. Very good. Yep, you knew that one. Good job. In the formation of chemical bond, okay, this is the same question they just asked you, but in the question they asked you before, the words chemical bonds were missing. Now we have to fill in another word. In the formation of chemical bonds, atoms gain, lose, or share what?
Electrons?
Electrons, right, with an S. Good job. Nice. Nice work. Okay. Now, covalent bonds demonstrate electron sharing, electron transfer, exchange of protons, or neutron sharing. Covalent bonds means what? What kind of bonding is that when you do what? Okay, covalent bonding. Atoms may also bond by sharing electrons rather than by exchanging them. So covalent bonds come from sharing electrons. Okay, you can watch the video below if you want, and it'll explain the difference between ionic bonding, where atoms give and take electrons, versus when they share them.
When atoms combine to form compounds, they can give up, accept, or share electrons to assemble an octet of electrons in their outer shells. In ionic bonding, an octet is formed when one or more valence electrons are transferred from one atom to another. In covalent bonding, the valence electrons are shared between atoms to form an octet. For example, an ionic bond is formed when sodium's one valence electron is transferred to fluorine, which has 7 valence electrons. Both atoms therefore achieve an octet of electrons in their outer shells. By losing one electron, sodium has a +1 charge. By gaining one electron, fluorine has a -1 charge. An ionic bond is the electrostatic force that holds ions together in ionic compounds. An example of a covalent bond is when two fluorine atoms, each of which has 7 valence electrons, share one electron so that both atoms achieve 8 valence electrons. Another example of a covalent bond is when hydrogen shares its 1 valence electron with fluorine, which has 7 valence electrons. Fluorine achieves an octet of electrons. Note that hydrogen in this compound has 2 electrons in its valence shell. This is the stable configuration of the first electron shell.
Okay, so covalent means they share, like co-workers, right? Covalent bonds means that the atoms are sharing electrons. And ionic bonds means that one kind of atom gives up an electron or loses an electron, the other one gains it. So in ionic bond, it's more like a trade system. But in a covalent bond, they're sharing it. Okay. So covalent bonds demonstrate electron sharing when they share electrons. All right. The blank electron shell can hold up to 2 electrons, while the blank electron shell can hold up to 8. So which electron shell can hold up to 2 electrons? Yeah. Mm-hmm. That's the only answer that fits. Okay. Good. Okay. Consider water molecules and the interaction between them. The bonds within each molecule. Okay, this is something we saw in the slides. The bonds within each water molecule between hydrogen and oxygen atoms are called blank. The attraction between two adjacent water molecules is called a blank bond. Okay, so the bonds between oxygen and hydrogen, and then the bonds between two adjacent water molecules. Okay, so we need to talk about bonds in water molecules. So we need to go down a little ways because we need to talk about water molecules, okay? In a polar covalent bond, electrons are shared, but not equally, such that the shared electrons move toward one of the bonded atoms. This results in a molecule with an uneven distribution of charges. Such a molecule is called polar. Unlike an ion, slightly negative, a polar molecule has an equal number of protons and electrons, but more of the electrons are at one end of the molecule, making that end slightly negative, while the other end of the molecule is slightly positive. Water is an important polar molecule. Many larger molecules, including carbohydrates, proteins, and nucleic acids, have polar regions and dissolve easily in water as a result. Unlike electrolytes, however, these molecules do not dissociate when they dissolve in water. They remain intact. Such water-soluble molecules are said to be hydrophilic. They like water. So if you go down, a little ways down, you can see here's your water molecule. You've got the oxygen, this big red atom in the middle, and you've got these two hydrogens that are attached. And this this oxygen molecule, I should say, is a bully. Remember your teacher said? And so it dominates these two hydrogen atoms. So there's hydrogen bonds. So if you scroll down, you can see the types of bonds there are. Water is a polar molecule. Water molecules have equal number of electrons and protons, but are polar because the electrons are shared unequally. Hydrogen bonding connects water molecules. So here you have, there's hydrogen bonds between the okay, so then you want to look at the, okay, scroll down. Molecules that lack polar regions, such as triglycerides and steroids, do not dissolve in water. Such molecules do dissolve in lipid and are said to be lipophilic. Water solubility and lipid solubility are important factors in drug delivery throughout the body. Typically, polar covalent bonds form where hydrogen atoms bond to oxygen or nitrogen atoms. So this is polar covalent bonds. The attraction of the positive hydrogen end of one polar molecule to the negative nitrogen or oxygen end of another is called a hydrogen bond. Okay. So what they're saying here is that hydrogen bonds the attraction of positive hydrogen to the oxygen end of another polar molecule is a hydrogen bond. Okay. Hydrogen bonds are weak yet stable. That is, they stay intact unless disturbed with either an increase or decrease in temperature or an interaction with other chemicals. A water molecule, for example, tends to form hydrogen bonds with other water molecules above 0 degrees Celsius. However, increased molecular movement breaks down the hydrogen bonds and water is a liquid. In contrast, below 0 degrees Celsius, the hydrogen bonds between water molecules are strong enough to form ice. So when you have between water molecules, you have hydrogen bonds, and within water molecules, you have polar bond. You have polar because they're not the same strength. I think that's the question they asked. Let's go back and look at the question again. Consider the the bonds within each molecule between, okay, so let me check something. Oh, no, not again. It happened to me. I believe that the bonds within water molecules are are polar, and then I think it's polar and hydrogen. I think it's polar and hydrogen for this. Within it is polar, and then they have hydrogen bonds between water molecules. I think that's what we read. Yeah, so bonds within a molecule cannot be hydrogen bonds. Hydrogen bonds only occur between molecules, between the hydrogen of one molecule and the oxygen of, okay. Yeah, so that's a good way to remember it. Hydrogen bonds cannot occur within molecules. Okay. That took a minute to figure out, but we did. They're gonna ask us another question about, yeah, okay. All right, so we're talking about the second and third electron shells. How many can I hold? How many electrons does the second and third? They want a number here. How many electron shells? How many electrons can I hold there in the second or third shell?
I think it's 8.
8, that's right. 8 is correct. That's right. We're gonna take the number. It did. Okay. It didn't say to write it out, so good job. Yeah, that's good. Let me, hold on, I did the same thing as yesterday. So this one says, let me keep that one. My cord, because I dropped my cord on the floor. So it says, compared to the strength of other types of chemical bonds, hydrogen bonds are relatively weak. They're not very strong. Hydrogen bonds are relatively weak bonds. You couldn't read that in the section that we just passed on, but those are relatively weak bonds. And okay, the electrons in the blank shell. Okay, they asked us this question earlier. They're asking it in a different form now. The electrons in the blank shell of an atom determine the reactivity and chemical behavior. This is either outermost or innermost. Which one determines the behavior of how the molecule or the atom is gonna act? What did we say? the electrons in the outermost shell of an atom. See that? Up at the top. The electrons in the outermost shell of an atom determine its chemical behavior. Okay, cool. Okay. What type of bonding is occurring between the water molecules in the figure? Now, notice it doesn't say between the hydrogens. It says between the water molecules. So when you there's 3 water molecules on the screen. What kind of bonds are holding the water molecules together?
I think it would be the first one.
I think it's the second one, hydrogen bonds. Because hydrogen bonds can only occur outside the nucleus of I think it's hydrogen bonds, bond water molecules. Yeah, hydrogen bonds, bond water. You can atoms that become, okay, you know the answer to this question. Atoms that become electrically charged due to the gain or loss of electrons are called what? What is the word for an electrically charged atom?
I think it's chemical bonds.
Well, they become chemically charged because of bonds, but once they bond, what do we call those atoms that are like if hydrogen bonds with fluorine, they bond, right? What do we call the charged atoms as a result of that? It's not an atom anymore. What is it?
Nucleus.
It's an ion. It's an ion. The nucleus is part of the atom. So the ions are the ones that are charged. They're called ions. You can look it up. If you want to look it up, you can look it up. So here, atoms that gain or lose electrons become electrically charged and are called ions. So what they did is they turned the sentence around. They said the atoms that gain or lose or that become electrically charged are called ions. So the atoms bond, however they bond, okay, by sharing or by trading electrons. And then those charged atoms are called ions after that. Okay. In large molecules, such as nucleic acids, DNA, polar regions are located in different parts of these molecules, can be attracted to each other, forming what kind of bonds? Okay. So typically, polar covalent bonds form where hydrogen atoms bond to oxygen or nitrogen atoms. Okay. The attraction of the positive hydrogen end of one polar molecule to the negative nitrogen or oxygen end of another molecule is a hydrogen bond. We read that before. Now, if you read about, okay, this isn't talking about nucleic acid. So I need to go to another part of the scroll. We need to think about nucleic acid. Go up. I think it probably went up from there. Yeah, go up a little bit. Okay. This is water molecules. Keep going up. This is water. Okay. Carbon atoms can form two. Okay, keep going up. I think it's before this. I remember reading it. I just don't remember where I read it from. Uh, Covalent bonding, hydrogen atom. Okay, this is still about hydrogen. Keep going up. I think it's for up in here. I'm looking for something with keep going. This is another, okay, this is ionic bonds. Okay. Okay. I know. All right, let me see about. I remember reading about nucleic acid. I just don't remember what I read. Hold on. Let me see about the bonds. oops, the bonds in DNA. Covalent bonds occur within each strand of DNA. And so the double DNA helix is held together by covalent and hydrogen. Covalent bonds occur within each linear strand. Hydrogen bonds are between the strands. So covalent bonds within and hydrogen between them. Let's go back to the question and see what they're asking. Are located, can be attracted to each other. Polar regions can be attracted to each other. In large molecules such as nucleic acids, polar region, okay, wait a second. Okay, so hold on. In large molecules, covalent or polar region can be attracted. I think that's hydrogen bonds. Because you wouldn't be able to form a covalent bond because you're outside of it. I think it would be hydrogen bonds. Yeah, it's hydrogen. A chemical bond between atoms that share, okay, what do we call, there's three kinds of bonds. So what do we call the kind that shares electrons? Do you remember? What we call the kind that shares electrons?
I think it's covalent bonds.
That's correct. That's covalent bonds. Very good. It's called a covalent bond. Nice. Nice job. Atoms of the same element. So if I had two elements of hydrogen or two elements of fluorine, what would I get? Would I get a molecule or would I get a compound? Okay. So If atoms of the same element bond, they produce molecules of that element. When atoms of different element bond, they are called compounds. Compounds. So water is a compound. It has hydrogen and oxygen. But like H2 would be hydrogen molecule. Okay. So a molecule is two of the same thing. Okay. Two of the same would be a molecule. Polar covalent bonds occur within water molecules, and hydrogen bonds occur between adjacent water molecules. That's true. Polar bonds occur within water molecules. You can't have a polar bond outside, outside the nucleus. So polar covalent bonds occur within water molecules. Hydrogen bonds occur between adjacent water molecules. That is true. That's a true question. Within a one, okay. The molecular formula provides information about the structural formula of a molecule, the types of atoms in a molecule, or the number of neutrons in an atom. What do you think? Yeah. The molecular formula provides information about what? A molecule. So if I give you like the molecular formula, like H2O is water, what does that tell you? What does that give you information about?
I think it would be the first one.
The structural formula? Okay, try it. I would venture to say it's probably the second one, but I'm not, because I don't think the structural formula is how they put it together. But look at the additional resources. Let's look at the additional resources and see what it says. A molecular formula represents the numbers and types of atoms in a molecule. Numbers and types of atoms in a molecule. It doesn't really tell you about their structure. Just from H2O, you can't really tell how it's structured because you don't know what the bonds are. But the numbers and types of atoms in a molecule. Okay. So the molecular formula provides information about the number, so the types of atoms in a molecule. So that would be the second one. Okay. Describe hydrogen bonds. They are very strong. No, they're not. They involve the ionization of the atom. They are relatively weak, or they can only form among non-polar molecules. Which of those is true? What have we learned about hydrogen bonds?
And I think it's this one,
They're
relatively weak.
relatively weak. Yeah, I think you're right. Good job. Nice. By definition, the atoms that are made during a chemical reaction are called what? So we have chemicals that create other chemicals, right? When we have a chemical reaction, like when we put hydrogen together with oxygen, we get water. What do we call the elements that are made? If you need help, you can look it up. So, chemical reactions form or break bonds between ions, molecules, generating new chemical combinations. For example, when two or more atoms, like hydrogen and oxygen, they're called reactants, bond to form a more complex structure called the product, the reaction is called synthesis. Such a reaction is symbolized in that way. When you decompose it, you have a reactant and they become products. So the thing you get is called a product. The things you put together are reactants. So reactant plus reactant equals product. So the things that are made are products. Is called products. Products. Okay, next question. The relatively weak, okay, back to hydrogen bonds. The relatively weak attraction between positive hydrogen and one polar molecule to the negative nitrogen or oxygen end of another polar molecule is called a, what kind of bond is that? Between hydrogen and to the oxygen end of another polar molecule.
I think it's ionic bond.
Okay, try it. Try it and see. Okay, this is a hydrogen bond because this is inside it's the molecules that are with each other, right? So this is the bonds that are between polar water molecules. Those are, so water molecules have hydrogen bonds that hold the hydrogen and oxygen together. And when you get water molecules that bond to each other, they form hydrogen bonds. Okay. Not ionic bonds. They're not ionic because they're not completely stable. Okay. Those are not ionic. There's hydrogen bonds and they're polar covalent, but they're not ionic. Okay. We have time for one more, I think, before I have to leave you for this session. Okay, let's see where we are. These weak bonds may provide substantial strength in proteins and occur between polar regions of a single molecule. Those are, if they're occurring between polar regions, then I think they would be, I don't know. These weak bonds may provide substantial strength in proteins. Hold on. Okay, let me, what am I gonna do here? Those are hydrogen bonds because they're relatively weak. They're hydrogen bonds. Those are hydrogen bonds. Okay. Okay, I need to leave you for this time. Okay. If you'd like to meet later tonight, maybe we can. I have to check with my other student. But I do have an appointment coming up in about 30 minutes and I need to prepare. Okay.
Okay.
So I'm going to say goodbye to you for now, but you got a good head start on chapter 2, I think. And this has a lot to do with the slides that she started. So I think we have a better chance of getting it done. Okay, but we'll talk about your next meetings in a little bit after I have a couple of things I have to take care of, and then I'll text you. Okay.
Okay, thank you.
You're welcome, Daniela. Take care now.
Okay, thank you, you too. Bye.
Bye.